Hello students. So in this video, let's start with the problems based on applications of trigonometry. So in the previous video, we have discussed about angle of elevation and angle of depression. So angle of elevation is formed whenever a person is watching something above z. If is watching something below, uh, then we say angle of depression is formed. Okay, and we also discussed when to use which ratio. Okay, if opposite side is given and adjacent side is required, or adjacent side is given and opposite side is required, we are going to use tan theta. If opposite is given, hypotenuse is required, or the vice versa, we are going to use sin theta. If adjacent and hypotenuse is given, we are going to use cos theta. Okay, the most used is tan theta, remember that. Now let's come to the first question. So in the first question, as you can see, a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Okay, find the height of the pole if the angle made by the rope with the ground level is 30 degree. So as you can see here, okay, the pole is AB is the pole. Okay, now we have to find the height of the pole. Let's say h is the height of the pole. That's what we have to find. Okay, and AC is the rope. Okay, AC is the rope. Okay, and the rope is making 30 degree with the ground. BC is the ground. Okay, so we have got a right angle triangle. Now according to the figure, 30 degree is the given angle, so opposite to 30 degree will become opposite side, and opposite to 90 degree will become hypotenuse, and the other one which becomes adjacent. Okay, if you observe the question carefully, the value of the hypotenuse is given, isn't it, 20 meter, and what we are supposed to find is h is actually the opposite side. So they have given us the hypotenuse and they're asking us to find the opposite side. Therefore we must use sine theta, because sine relates opposite and hypotenuse. Okay, so in triangle, or first let's take, let h be the height of the pole. Let h be the height of the pole. Therefore in triangle ABC, angle B is 90 degree. We are just saying that it's a right angle triangle. Now I'll be using sine theta. Here theta is 30 degree. So sine 30, that is opposite to 30, is AB, right? Basically, what is sine theta? Opposite by hypotenuse. So which is the opposite side? AB is the opposite side, AC is the hypotenuse. So, but we know that sine 30 degree is 1 by 2, and AB value is h, that is the height of the pole, and AC value is 20. Let's cross multiply, or let's send this 20 in the denominator to the other side. So it becomes half into 20 equal to h. Therefore, half into 20 is how much? 10, right? So therefore, h is equal to 10 meter. Therefore, the height of the pole will be 10 meter. Very simple. We have to just see what's given and what's required. Based on that, we'll be choosing the trigonometric ratio. Okay, let's get into the second question. In the second question, a tree breaks due to a storm and the broken part bends so that the top of the ground, top of the tree touches the ground, making an angle 30 degree with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meter. Find the height of the tree. Okay, let's say we had a tree like this. Okay, randomly let's just draw. Okay, we had a tree like this. Okay, and this is the ground level. Okay, let's say we had a tree, and let's say due to the storm, okay, the tree breaks at this point and the broken part is touching the ground. Okay, the broken part is actually touching the ground. Okay, now if you observe carefully here, what we have got here is a right angle triangle, isn't it? So let me draw it properly. Okay, let's say this let's say let me draw a straight line itself. Okay, let's say this AB is the total height of the tree, and let's say due to the storm the tree is breaking at this point. Let's say it is C. The broken part is what? AC is the broken part, and that broken part is bending towards the ground, isn't it? Let me draw that also. Okay, so that broken part A will come here, isn't it? Now BA will be the ground. The bottom part is the ground. Okay. So this is the broken part. Okay. Which is bent down. Okay. While bending, the broken part is making an angle of 30 degrees with the ground. And this is the 90 degree because the tree will be perpendicular to the ground. Now, according to the figure, if this is 90 degree, this becomes CA becomes hypotenuse. Opposite to the given angle becomes opposite side and the remaining becomes adjacent. Okay. And what they have given is the distance from the foot of the tree. Foot of the tree is B is the foot of the tree and top of the tree is A. This distance is 8 meter. Okay. They have given this distance. Okay. Now what we have to find is the height of the tree, total height of the tree. Remember, the total height of the tree is actually CB plus AC, isn't it? This length plus this length, isn't it? That is the total height of the tree, which means we have to find CB. Also, we have to find AC. Instead of finding this AC, let's find this one. Okay, both are one and the same, isn't it? So if you observe, if you want to find CB, that is you have to find opposite side. You should also find the hypotenuse, isn't it? Because that is AC. So here we have to find both opposite and hypotenuse. What is given? Adjacent is given. Okay. Now, since adjacent is given and you need opposite, let's use tan theta first. Okay. In triangle ABC, again B is 90 degree. We will be using here theta is 30 degree. Okay. First, let's use tan theta, that is tan 30 degree. Tan 30 is opposite by adjacent. Opposite by adjacent is the tan. What is opposite here? CB is the opposite and adjacent is BA or AB. Now tan 30 is 1 over root 3. That will be equal to CB is opposite side, which we have to find it, and BA is given as 8. Okay. Let's send this 8 to the other side. So it become 1 by root 3 into 8 is equal to CB. Therefore, CB is equal to 1 into 8 is 8, root 3 as it is. Okay. What we have found is just CB. Still, we have to find AC. Okay. Now, adjacent side is given. We have to find hypotenuse. Let's use cos theta. So, cos 30 degree. Cos is adjacent by hypotenuse, isn't it? Cos is adjacent by hypotenuse. What is our adjacent here? Adjacent is BA, isn't it? And hypotenuse is CA. So we know that cos 30 is root 3 by 2. That will be equal to BA. BA is 8 and CA is, we have to find it. Okay. So if you cross multiply, root 3 into CA is equal to 8 into 2 is 16. Therefore, CA becomes 16 by root 3. Okay. Now, the actual thing is we have to find the height of the tree. Okay. As I told you, height of the tree is actually equal to CB plus CA, isn't it? What is CB? 8 by root 3. What is CA? 16 by root 3. Since the denominators are same, we can add it. So it becomes the root 3 is the LCM. 16 plus 8 is 24. Remember, we are not supposed to have irrational number in the denominator. So let's rationalize. Okay. So 24 by root 3 multiply and divide by root 3. So 24 into root 3 becomes 24 root 3. Root 3 into root 3 is root 3 square. So square and root gets cancelled. So we are left with 24 root 3 by 3. 3 ones are 3, 8s are. Therefore, the final answer, height of the tree will be 8 root 3. That will be the final answer. So here, as you can see, AB was the total length. To find AB, we had to find CB and CA. So finding this CA is as same as finding this CA because both are one and the same. This is the broken part that is bent down. Okay. So we found the value of the height of the tree. Okay. Let's get into the next question. In the next question, a contractor plans to install 2 slides for the children to play in park. Okay. So he's installing 2 slides. Okay. Not 1 slide, is installing 2 slides. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter and is inclined at an angle of 30 degree. Okay. Whereas for the elder children, she wants to have the steep slide at a height of 3 meter and inclined at an angle of 60 degree to the ground. What should be the length of the slide in each place? Okay. Now, according to the question, the contractor, she wants to construct two slides. One slide, okay, okay, let's say the slide is like this, okay. This is where we have steps, isn't it? We climb and we slide over here, isn't it? So let's say this is the slide, okay. This is for the children below the age of 5 years, okay. And let's name it as ABC. A, B, C. And obviously, this will be 90 degrees. And this height is given as how much? 1.5 meter. That's the height. Okay. Now, what we have to find this length of the slide. That is AC. Okay. And the smaller one is making an angle of 30 degree with the ground. So this is the angle 30 degree with the ground. Okay. Here we have to find the value of the hypotenuse. Okay. This will be hypotenuse. Opposite to the given angle is opposite side, and the remaining one is adjacent. Okay. This is regarding the first slide. So in the first slide, let's find the length. That is, let's find AC. Again, in triangle ABC, angle B is equal to 90 degree. As you can see, they have given us the opposite side and they're asking us to find the hypotenuse. So we are going to use sine theta. So sine 30 degrees, okay, is equal to opposite by hypotenuse. So here opposite is AB, hypotenuse is AC. So sine 30 is 1 by 2, AB is 1.5 and AC we have to find it. Cross multiply, 1 into AC is AC, 1.5 into 2 is 3 meters. Therefore, the value of AC is 3 meters. Okay, this is for the smaller children. For the elder ones, she has to again create another slide, isn't it? For that, what we'll do is, according to the question, let's construct one more slide which is bigger, okay, which is bigger in size, obviously, for bigger children. Let's say this is the slide. Okay, let's say P Q R. Let's say this is 90 degree, and according to the question, the height of the slide is 3 meter. Again, we have to find the length. Here the angle made is 60 degrees. Again, we have to find this length. Okay, so this will become hypotenuse. Again, this is opposite and this is adjacent. The same logic, they have given us opposite and they're asking us to find hypotenuse. So in triangle PQR, angle Q is 90 degree. Therefore, we are going to use sine because opposite is given and they're asking adjacent. So sine 60 is equal to opposite, that is PQ, hypotenuse is PR. So sine 60 degrees, we know that it is root 3 by 2. PQ is 3 meters and PR is, we have to find it. So let's cross multiply it. PR into root 3 is PR root 3. 3 into 2 is 6. Therefore, PR becomes 6 by root 3. We are not supposed to have a rational number in the denominator. So let's rationalize it. So it becomes 6 into root 3 is 6 root 3. Root 3 into root 3 is root 3 square. So square and root gets cancelled. So we are left with 6 root 3 by 3. So we can cancel 3 ones are 3 twos are. Therefore, PR becomes 2 root 3 meters. That's the length of the slide of the bigger one, bigger slide. Okay. So as you can see, we have found both the slides length in the question. Okay. So let's get to the next question. The angle of elevation of the top of a tower from a point on the ground, which is 30 meters away from the foot of the tower, is 30 degrees. Find the height of the tower. A very easy question. See, what we have got is a tower, isn't it? We have got a tower. Let's say AB is the tower. Okay. From a point on the ground, let's say C is the point on the ground. From that point, we are watching the top of the tower. Okay. So obviously, if you're watching something above, it is angle of elevation, isn't it? Let's join B and C, which is the ground. Okay. So this angle of elevation is given as 30 degree. Okay. The angle of elevation of the top of a tower from a point on the ground, which is 30 meter away from the foot of the tower. So they have given the distance of B and C, distance between B and C. That is, this point C is at a distance of 30 meter from the foot of the tower. Foot of the tower in the sense B is the foot of the tower. Okay, the base. From this point B to C, the distance is 30 meter. From there, we are watching the top of the tower. So the angle of elevation is found to be 30 degrees. What we have to find is the height of the tower. That is the value of AB that we have to find. From the figure, this becomes opposite and this becomes adjacent, and opposite to 90 degrees hypotenuse. Okay. So here AB is the tower, isn't it? So we have to find the height of the tower. Let H be the, let me write it properly. Let H be the height of the tower. As you can see, they have given us the adjacent side. The value of the adjacent side is 30 meter. What we have to find is the AB, that is opposite side. So opposite side is required and adjacent is given. So we are going to make use of tan. Okay. In triangle ABC, angle B is equal to 90 degree. Okay. We are going to make use of tan. Tan 30 degrees, that is equal to opposite by adjacent. Opposite is AB, adjacent is BC. Tan 30 is 1 by root 3. AB value we have to find it, and BC value is 30. So let's send 30 to the other side. So it will become 1 by root 3 into 30 is equal to AB. Or you can write, therefore, 1 into 30 is 30, root 3 as it is, 30 by root 3. Remember, we are not supposed to have a irrational number in the denominator, so let's rationalize it. So 30 into root 3 is 30 root 3. Root 3 into root 3 is root 3 whole square. So square and root gets cancelled. What happens in the next step? What we have got is 30 root 3 divided by 3. So 3 ones are 3 tens are. Therefore, the answer is 10 root 3 meters. That's the height of the tower, isn't it? Okay, students, let's continue the next problem. So here we have got a kite which is flying at a height of 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string, assuming that there is no slack in the string. There is no slack in the sense the string is very stiff or it is very tight. Okay, let's say this is a string that is tied to the ground. Okay, let's say it is tied at this point and we have got a kite here. Let's say we have got a kite here at this point A. Okay, and B is the point where it is tied to the ground, and the kite is flying at a height. Remember, the height is always a perpendicular distance. Okay, so we take the perpendicular distance to be the height from the ground. Okay, so this height, that is AC, the height at which it is flying is 60 meter. So they have given us the value of AC. Okay, let's join B and C. Okay, now the string BA is the string. Okay, this is the string, or let me write it inside. This is the string. Okay, now this string is making an angle of how much? 60 degree with the ground. This is the ground, G and D. Let me write it as G and D, ground. Okay, and the perpendicular distance is 60 meter. Now according to the question, the opposite to 60 degrees is the opposite side, and opposite to 90 degrees is the hypotenuse, and the remaining one will be adjacent. Now observe the question. What should we find? We have to find the length of the string. The string is AB, right? We have to find the length of AB. That is, we have to find hypotenuse. What is given? The value of opposite side, that is AC value, 60 meter is given. So opposite is given, hypotenuse should be found. Therefore, we are going to use sine theta. So in triangle ABC, angle C is 90 degrees. We are going to make use of sine theta. Sine theta is 60 degree. Sine 60 degree is opposite by hypotenuse. Opposite is AC, hypotenuse is AB. Sine 60, as we know, it is root 3 by 2. AC value is 60 meter. And AB value should be found. So let's cross multiply. Root 3 into AB is root 3 AB. 60 into 2 is 120. Therefore, AB becomes 120 by root 3. Again, we should not have irrational number. So let's rationalize it. So what do we get? AB is equal to 120 into root 3 is 120 root 3. Root 3 into root 3 is, I'm sorry, root 3 into root 3 is root 3 square. So let me continue here. Therefore, it becomes AB is equal to 120 root 3 divided by 3. So 3 ones are 3 40s are. Therefore, the length of the string is 40 root 3 meters. Remember, if they have given the value of root 3, we have to substitute and calculate it. Anyhow, they have not given the value of root 3 here. So we are not going to substitute and calculate it. Okay. So it's very simple. What we have to do is initially we have to draw the figure properly. If the figure is drawn properly, 50% is done. Then we have to analyze what is required and what is given. Based on that, we'll choose the trigonometry ratio. We will get the answer. So we'll continue the next problem in the next video. Thank you, students.